bridge type step of cyclo converter. Now as shown in this figure, the positive bridge converter consists of a SCR TP1, TP2, TP3 and TP4. Now, similarly, the negative bridge consists of a SCR TN1, TN2, TN3 and TN4. Now that means 8 SCRs are used in this type of cyclo converter. Now the two fully bridge control, that means this positive and negatives, they are connected in anti-parallel. Now during this positive half cycle of output, the bridge 1 is responsible for the flow of load current. Similarly, during the negative half cycle output, current passing through the load is responsible by bridge 2. Now, both bridges are not conduct simultaneously, otherwise short circuit is occurred. So now as shown in this figure, during the positive half cycle of input, terminal A becomes positive with respect to terminal B. So now during this period, the SCR TP1 and TP4 are forward biased. Here TP1 and TP4 are forward biased from bridge 1, and similarly SCR TN1 and TN4 are also forward biased from this bridge 2. Now at the instant 0, here at the instant 0, the SCR TP1 and TP4 are turned on. TP1 and TP4 are turned on. So the load current is positive, and the load current flows through the path from A terminal to TP1, then C, load, then to D, and then TP4, and then B terminal of the supply. So during this period, the load voltage follows the envelope of positive cycle. Here you can see. Now at instant 1, the SCR TP1 and TP4 are turned off by commutating by the force commutating, and that time the thyristor or SCR TN4 and TN1 are turned on. Here N4 and the TN1 are turned on. So the currents passing through this load becomes negative, and the current flows through the path from B terminal, here the A terminal, then TN4, then B terminal, then load, then C terminal, then here TN1, and then B terminal of the supply. So here you can say that the current passing through this load, it is in reverse direction, and the load voltage also follows the envelope of negative from the negative supply. Now at the time of second, at the instant 2, the SCR TN4 and TN1 are turned off by force commutation, and that time thyristor TP1 and TP4 are turned on again. So due to this, the current flows from A terminal to the TP1, then C terminal, then load, then D, then TP4, and then B terminal of the supply. So during this time, the current passing through load is positive, and the load voltage also follows the positive input cycle. Now similarly, we can on or off alternatively at the time of 3, 4 and 5. And during this, after the complete of this 5 instant, one positive cycle of the input is coupled. Now during the negative cycle of the inputs, the terminal B is positive with respect to terminal A. So during this time, TN2 and TN3 are forward bias from negative group converter, and the SCR TP2 and TP3 are forward bias from this bridge, positive bridge or bridge number 1. Now at the instant 6, here we can say at the instant 6, the thyristor TN4 and TN1 are turned off by host commutation. At that time, thyristor TP2 or SCR TP2 or TP3 are turned on by applying the proper gate pulse. So now this time the currents is flow from here. Currents flow from B terminal positive. That means it starts flow from B terminal to here B terminal is positive. So here TN3. Just a minute. T is positive. So at 6 times TP2 or here, yes, thyristor TP2 and TP3 are turned on. So here the current flows from B terminal to TP2, then C, then load, then D terminal, then TP3, then A terminal of the supply. So here you can say that the current flow from load from C to B. That means the load current is positive and the load voltage follows the positive envelope of the input. Now at instant 7, the SCR TP2 and TP3 are turned off by force commutation, and that time SCR TN2 and TN3 are turned on. TN2 and TN3. So that time, due to this current flow from B terminal to TN3, then B terminal, then load, then C, then TN2, and then A terminal. So here the current flows in the reverse direction. That means the load current is negative and the load voltage load voltage follows the negative input cycle. So here we can see 8, 9, 10, 11 and 12 instance the SCR are turned off alternatively. And as shown in this figure, after completion of this 12 instance, one input cycle is completed. And we can also say that the output voltage frequency is greater than 6 times of input frequency. That means output frequency F0 is equal to 6 Fi. So if the supply frequency is 50 Hz, then the output frequency becomes 6 into 50 is equal to 300 Hz. Now application of cyclo converter. It is used in electric traction. It is also used for the constant frequency AC supply of variable speed aircraft and the sea to achieve the constant frequency AC supply. Third, it is also used for speed control of high power AC drive. Fourth, it is also used in high voltage DC HV DC transmission, high voltage DC transmission line. It is also used in static VAR generation. It's another application. It is used in induction heating. And 7, gearless ball mill track.